I think welcome everybody. This is the third webinar in our series in preparation for Antalya, which is the 50-year anniversary this year, and the symposium being hosted by the Cleanroom Society of Turkey in Antalya between the 11th and 13th of October. In today's webinar, we're going to talk about case study in hospital pharmacy ACU. It's jointly organised between the Irish Cleanroom Society and the Nordic. And we have a number of speakers here who are going to talk directly in a case study, and then we'll finish with Jukka Vasara from North 3 Nordic, who will talk about the wider aspects of HVAC in wider hospital pharmacies from a European perspective. In the meantime, while we're waiting for other attendees to dial in, we're going to open a few polls. So if you look to the top right of your screen, you should be able to click on a button which will show you polls, which is just giving us some indication of where you're coming from your perspective. If you're involved in hospital pharmacy ACUs, whether a pharmacist or in tech support or a vendor supporting it or other, it gives us a better idea as we go through the seminar on that. We leave that poll open to you for a while and see what the responses are. You should be able to see the responses coming up at the same time. So I suggest the speakers, you might as well enter the poll and give an answer yourselves, right? I suppose from our perspective, we're coming in on the vendor side. So what we'll do is I think we'll leave this poll question open for a minute or two. So Chris, it's now 5 past. Nercida, we need you to tell us just when attendees, give us an idea of attendees. So, because I think we might give it another few minutes and then we might start probably. I think.
Can you see the results of the poll right now?
000 is all we can see.
Are you seeing numbers in the poll results?
Publish it. I need to finish polling to.
Okay, the results. Okay.
Publish the results.
So I'd wait a few minutes. No, I wouldn't.
No, I would leave it
just yet.
I would leave it open. You see that for 5 to 10 past 13:10.
So, Chris, we've given ourselves a few minutes just to get people organised. So we've got it according to our programme, we've got about another 5 minutes or so to take up polls. Get a chance to do some introductions, and then we'll allow Colin to start closer to the 12:30 mark. Okay.
Yep. So.
Yeah. So, Chris, we may need to just get Nercida to advise us when we've got a sufficient number of attendees that we'll get ourselves going then, right?
Yeah. So what we can do, Connor, in the meantime, I'll introduce myself and then we can go around to Colin, Peter, Barry. And,
that's a great idea. I agree.
Yeah. So, guys, Chris Delaney is my name. I'm training and education convener for the Irish Cleanroom Society. So I suppose the Irish Cleanroom Society is just give you a background. Connor is chairman. He's also chairman of the ISCC’22. I suppose the main goal of the Irish Cleanroom Society is to education and training, and also to spread the knowledge and spread our knowledge. It's a non-for-profit organisation. So how we operate, or how we operate from sponsorship. I suppose, in the ISCC’22, the Irish Cleanroom Society has been there from many years. So as Connor said earlier, this year is the 50th year of the Irish ISCC’22. So Connor is chairman. So for Ireland, it's a big thing, and I just hope there that going forward, the guys that we have presenting today, we will get closer contacts, and we look at other events as well. So that's just myself. What I'll do is, Barry, I'll just get you to introduce yourself. I know you're going to introduce yourself for the slides, but just a quick overview. A minute or two.
Yeah, thanks, Chris. Hi, everyone. I'm Barry Fitzgerald, Ecolab. I'm an account manager with Ecolab, so covering the east and south of the country, both hospital and industry accounts with the company now nearly 7 years. So worked under Connor's guidance with St. Vincent's University Hospital, so looking forward to sharing that case study later in the presentation. That's it, Chris.
Okay, thanks Barry. And just Ecolab have been one of the main sponsors of the Irish Cleanroom Society over the last probably 15 years since I've been involved in it. So as a society, Barry, I want to thank yourselves and thank you for today. Peter, do you want to say hello?
Hello all. My name is Peter Marin. I'm a director here at ClearSphere down in Cork. We're a turnkey cleanroom provider. We like to assist with cleanroom design in the early stages, go right through the build, take on our specialist subcontractors, mechanical, electrical, and whatever is needed, and deliver as complete a package as possible to the end user, and that includes verification activities and ongoing support thereafter for clients, ensuring continued compliance with the relevant ISO 14644 standard. Thank you very much.
Thanks, Peter. Colin, do you want to just...
Sure. Hi, everybody. My name is Colin Buckley. I'm Senior Project Manager with ClearSphere. I've been with the company since 1999. So I've quite a number of years right through from installation through to verification and on to project managing the projects. So I oversee the Vincent's University aseptic compounding suite installation, and I'll be giving a talk there in a while on our journey in conjunction with Connor from 3 Dimension. Okay, thank you.
Okay, thanks Colin and thanks Peter. Again guys, I just want to, from the Irish Cleanroom Society perspective, I want to thank you for your support and help over the years, and long may it last. It's great working with guys like yourselves and Ecolabs and all that, so we do appreciate that. Later we're going to have Mike Wood from Ecolab as well, and Kirsten McKeown. I don't know if Lenny is on yet. Is she Connor? I don't think so. Anyway, I suppose what we'll do is let's see that we can publish the first poll, the results. The fact that we can't see and when he's on, we're talking to ourselves. Okay, so the pharmacist 6%, tech support 25%, and vendor 38%, and other is 31%. So I think from that there's a good mix of people. So will we look at the second poll, Narcida?
I'm sorry, I couldn't quite catch what you said.
Have we a second poll? Second poll?
Second poll.
So we're going to do this poll, and then guys, what we'll do, we'll have the first presentation, and then we might do the poll. So if you do work in a supporter hospital, pharmacy, ACU, what primary engineering control do you use in terms of clean air equipment? Isolators, class 2 BSCs, isolators, class 2 BSCs, or UDAFs. So again, guys, we could just have a vote and let's see what the results are. We'll just give that a few minutes there. we'll just give it 2 more minutes, and then what we'll do is we'll start. Colin will get you to present.
Sure.
I'm still glad to do it.
Okay, so on the SEDA, we can publish the results and see what they were, please. Okay, so it's a good split. Isolators 30%, 20% for isolators for CABS and 22 BSC. Guys, good split there. So what I'm going to do now is I'm going to ask Colin to start our seminar.
Okay.
So you can start, Connor, and
sorry, Chris.
Yeah.
Chris, could you advise people that the meeting is being recorded, and that by joining in, they're giving their permission to do that. I'd also suggest if you wanted, there was 2 other poll questions. You may want to go to those, or you can do those later.
We're going to do them at the end of Colin's presentation.
That's okay. That's okay.
Yeah.
I'm going to leave that with you. Leanie is not able to connect or see this, so what we might do is after Colin, we'll try and get Leanie in to say a few words with you, Chris. Is that okay?
Yeah, 100%. Yeah.
So if that's okay, I'm going to hand over to you, Chris. I'll let you continue to lead this, and I'll join you later. Is that okay?
Yeah. 100%,
okay.
Yeah.
Over to you. Cheers.
So Colin Buckley from Clearsphere is going to give a presentation. Colin, I'll let you give the heading of the presentation.
Sure.
Clean room, and take it away. Thanks.
Thanks, Chris. I'll just share my screen here now. And you might just let me know if you can see it.
Yes, very good. Yeah.
Okay. So, listen, thank you all for joining us today. My name is Colin Buckley. I'm with Clearsphere down in Cork. We were commissioned to design and build turnkey aseptic compounding suite at St. Vincent's University Hospital, which includes ISO 5, ISO 7 and ISO 8 rooms. And the project included the mechanical and electrical interface associated with that as well. And I'm here with Peter Martin, as was mentioned earlier. So, okay. So, I suppose we start off. This is the picture of the finished compounding room in Vincent's Hospital, just to give you an overview of what the client ended up with here, where all the drugs, the cytotoxic drugs, are being processed. So, who are Clearsphere? I guess we were established in 1989. We operate ISO 9001, 14001 and 45001. We have in-house engineering BIM capabilities, including 3D and full in-house design. Our head office is located in Cork, and we're very fortunate, I guess, because we're located in the heart of the pharma industry with Pfizer's and all the other good pharmaceutical companies around us, like Janssen Bio, etc. So we've a lot of experience in the cleanroom environment. So we're one of the leading cleanroom and containment engineering providers in Ireland, and we work throughout Europe as well and other parts of the world. The project approach, I guess, we we get Vincent's Hospital is we started off by defining the scope, and realistically, I suppose the best way to do that is to have the chat directly with the client and the people that are going to be using the facility. So the client, speaking to the client, we find out what their expectations are in terms of product and product selection, what equipment will be going into the facility, who will be the decision makers, I guess. And like I say, a lot of these big projects, you don't actually get to meet the end users until you've handed over the project and they start taking over the facility. So in this situation, it was great because we were able to work alongside 3Dimension, Conor Murray and 3Dimension, and the actual pharmacists that are using the facility. So we were able to get their input from day one, which was of huge benefit. We find out, item number 4 there, we find out what are the timelines involved. And I guess on this particular project, it was unique in that it landed right in the middle of the first lockdown. So it was interesting times. Now, luckily enough, we had all the project materials and fabric procured. So it didn't have a huge impact, only the time that the actual project was shut down on site, which wasn't that long, to be fair. And then we obviously have ongoing discussions with the design team, being the likes of Arabs, the architects of Conor Mahan, 3Dimension, etc. So that's looking at it from the client expectation. You've the standards and regulations that we design and construct to. So you have the GMP, the ISO classifications, the ISO 14644, etc. ATEX considerations where applicable. Didn't fall into this particular category as such, but ESD requirements like flooring, etc. Building codes, Part M, and the access, disability access, etc. So we move on then to the likes of building constraints. In terms of building constraints, I suppose you're looking at access and egress, how to get the materials, etc., into the site. How do you get people in and out of the site? And in a lot of the hospital projects, you're dealing with unique situations whereby you don't have a big site to work on. You're working in either a city or you're working alongside residential areas, etc. So we've quite a bit of experience in dealing with getting people in and out, parking, etc. for people that are working there. The second item is that you're working in a live site. So whilst we're constructing inside in the construction zone, next door you may be working alongside a hospital that's fully operational, as was the case with Vincent's. So you need to be very mindful of what is going on outside of your environment and how you have an effect on that in terms of noise, in terms of access and egress, and in terms of orders from different construction activities, etc. But primarily noise is the big one. Environmental impacts. Again, I speak about the locality because not only are you dealing with the people inside in the hospital, you're also dealing with the local residents who are directly outside the hospital, and trying to control materials coming in and out, that you're not upsetting the neighbours, is very important as well, and parking, etc. So it's very basic stuff, but it all has to be considered, to be fair, as well. In terms of the facility constraints, then you have headroom, for example. So what is the available space to build and construct the facility in? And I guess the space that you give to the actual compounding rooms themselves and where the pharmacists operate, equally important is the space you give to the technical and interstitial space above that area, to allow for proper design, to allow for ease of maintenance, and to allow for access from a maintenance point of view, etc. And that in fairness, in terms of Vincent's Hospital, we were spoiled with the amount of space we were given, because there was more space above the ceiling than there was actually within the rooms, which meant you could size your ductwork, etc. in without any major constraints, because a lot of times these pharmacies can tend to be put in a basement or you're working between a floor and a slab space, which is quite constrained. So headroom was very, very beneficial here. And from a point of view, it meant we were able to install attenuators on every leg of ductwork, which allowed the facility to be super quiet in the end. Like, so we had readings of 32, 33 decibels, which was very, very good. Moving on, then you've steel and concrete mezz purlins, basically how you're going to support the structures that you're building. So that's the nuts and bolts of how the fabric gets built and how they get installed. Fire regulations, we'll come to that further down the presentation, where we've got fire compartments, the likes of storerooms, etc. like that. We'll touch on that later. The power, what is the available power in the area, etc. And any planning constraints as well. So then I guess we move on to the build, and as Steve Jobs once said, if you define the problem correctly, you almost have the solution, which is very, very true. So we spoke there about fire constraints. So on Vincent's Hospital, we have a storeroom as part of the facility, and as part of that, the storeroom had a fire-rated envelope. So what you'll see here on the left-hand side is one of the lobbies where you transfer the materials from outside through the pass-through hatch to the facility, and vice versa. The pass-through hatch on the left-hand side was installed in a standard wall, so it's a non-fire-rated pass-through hatch. Whereas the photograph you're looking at on the right-hand side is within the compounding storeroom, and that is within a fire-rated envelope. So the same pass-through hatch obviously needs to be a lot bigger, a lot more involved in the engineering of it. So that's a fire-rated pass-through hatch for getting materials in and out of the store. Likewise, you'll see the likes, if I just zoom in here, you'll see the likes of the intercoms, where on the left-hand side, it's flush within the cleanroom panel. However, on the fire-rated panel, it's surface mounted, because you also can't impede or you can't compromise the integrity of the cleanroom panels. But the beauty, I guess, of both rooms and both applications, fire-rated versus non-fire-rated, is our partners Kingspan provide both panels. So they actually can provide the very same chemical resistant skin on the fire-rated panels as they do on the main compounding room panel. So you don't have to compromise on the quality of the fabric being installed over the fire-rated capabilities of it. So the project approach.
Colin, just before you go on there, just anybody wants to ask any questions, you can use the chat line and we'll pick them up at the end of it. I think that's probably the best way of doing it. Sorry, Colin.
No, you're fine, Chris. Yeah. From a project approach, so from a quality perspective, we operate to the ISO and our own internal IMS system. So we document all the from a purchasing point of view, right through to inspections, etc., of materials through our internal management system, and we work to make sure that all the products selected are CE approved. Our own ISO and our management system, we are in constant feedback with our suppliers as well to give feedback, and sometimes you'll find some of the feedback is constructive. It may be negative, but it can be constructive as well. So we're in constant contact with our suppliers, and we monitor and give our feedback to our suppliers. And again, then our documentation is all through our IMS system, through to the likes of the installation verifications, the operation verifications, and the performance verifications. So everything is documented right through from start to finish. Safety is obviously a huge factor and is equally as important. So again, our integrated management system will cater for all the safety aspects of training certs, site audits from a point of view of our safety officer attending site, going through the audits, going through the inspection reports for lifting equipment, etc. and all our own internal staff as well, and the training records, and we full matrix for all our guys as to the training that I've got from a safety perspective, from MEWPs right through to SafePass and all the other good stuff. We have our permit system, we have our full permitting system as well, SPAs, all that good stuff as part of that IMS system, which leads into the documentation. Program. So from the client's perspective, they're going to be most concerned, I suppose, and interested in what the program is, and from a construction program, installation, commissioning, etc. So, as I say, in the case of the St. Vincent's project, construction program was somewhat hampered with COVID. However, the majority of the project was executed, luckily enough. So by the time there was a decision made to go back and open up sites, materials, etc. were there, so we were able to continue with the program. We operate kind of a deliver just on time, not to have materials sitting around, especially we spoke about the locality and the live environments of, say, hospitals where you don't have a huge amount of storage space, so it's important to schedule and have materials delivered in a just on time system. And then commissioning in a suite such as this is most important. So further down the slideshow, we'll see the example of the commissioning program we presented for Vincent's, taking it right through all the different elements of commissioning, from BMS right through to installation verifications and performance verifications, etc. And with any project like this, I guess from the design team's point of view, we're very well familiar with the overall project and the nuts and bolts of how it's made up, etc. But from a client's perspective, they're taking on a huge monster that is new to them. So at ClearSphere, like what we like to offer a soft landings protocol, whereby we're on the end of the phone. Once the job is commissioned, a lot of times the project is finished, PCE is awarded and the project is finished. However, with something like this, we operate basically a follow-up with the client. So we schedule meetings on an ongoing basis for a period of 6 months or 12 months, whatever is required, so that we're on the end of the line. We're not after disappearing once the project is finished, and it just gives kind of reassurance to the client as well that they'll have backup should they need it. And then from a servicing point of view, obviously you've all the standard warranties, etc. that come with all the products. ClearSphere, we have our service team on the road as well, so we follow up. We actually have the maintenance contract to requalify the compounding room inside in St. Vincent's as well, so we have continual contact with the guys there as well, giving feedback, and we get feedback from the guys as well, because once the client gets their feet under the table, they'll find they might need a little bit of a tweak here or there once they start using the facility. So that's the project approach. But where we would have started with Vincent's was in the URS. We would have been presented with the slide you're seeing here, which basically gives an overall outline and footprint of the facility, indicating the classifications required, indicating the general size of the area, what are the pressure differentials, etc. that are required, and from there we can then start designing, because we can start setting out doing the calculations on AHUs, duct sizing, etc., and basically take it through to the technical submittal stage. So here you can see coming from outside, you have a differential pressure of plus 15 pascals going into the entrance lobby, and then it cascades up from there, another plus 15 pascals into first stage change. Again, 15 pascals into second stage, and 20. So you end up with a total of 65 pascals differential to atmosphere, or your reference point, which was just outside the pharmacy here. So that would have been primarily our starting point for design. From that, we start generating our P&IDs, and with the P&IDs, we can set out the AHU, the attenuators are shown there on the P&IDs, your supplies, your supply flow rate. I know it's probably quite hard to see that there, but essentially that's the line diagram for the entire suite, showing your chemical extracts for each of the isolators. So what you'll notice is on the first photograph, you'll see there was 4 isolators in the picture. So the facility is designed for 6. There's currently 4 installed with the capability of upping that to 6 should they require it. It's all the mechanical ductwork, electrics, etc. are all installed, ready to go. So there's very little invasive surgery. There's no invasive surgery to add 2 new isolators should they require it if capacity increases. ClearSphere then, our own in-house BIM engineer, will start designing and start laying out the facility using our Revit and start installing the actual panels in 3D format. This is a plan view, but it actually forms a 3D rendered model of the actual facility. So again, you can see here coming from outside, you're into the first stage lobby. You have the fire rated pass-through hatches we looked at in the photograph earlier. You're into the first stage gowning. You can go then from there into the aseptic prep room and into the storeroom here, which is outlined. That's the fire compartment we spoke about earlier as well. You can come in here then from the first stage into the second stage gowning where you have to regown, and go into the compounding room from there where all the isolators are located. Back out here, you don't need to enter the facility. You can enter the aseptic office from outside. So the flow of personnel is controlled, let's say, coming from outside into the ISO 5, ISO 7s and so on. So you minimize unnecessary traffic, I guess, by the way the layout is done here. And then that's your collection lobby here for collecting and bringing goods in. Again, this is just a snip of the drawings that are produced from that model. So everything is color coded for the different grade areas. You the different color coding doors, and you'll see that throughout now in photographs, etc. And it just gives a perspective of what the actual physical heights that are available within the room. There's additional drawings that went along with this, outlining all the furniture that was being installed as well, so the client could see what they should expect, I suppose. And there was a lot of time spent on the BIM modelling, so that there's as much time goes into BIM modelling and setting the facility out and clash detection, etc., as there is in the construction, because it's a lot easier to actually rectify issues on paper or on the screen than actually doing it in real life, and it just it makes the project a lot more efficient. So again, talking about BIM coordination, as I say, what's below the ceiling and what's inside in the suite is obviously what the end users, the pharmacists, are most interested in. There's as much goes on above the ceiling as in terms of design, and where I spoke about clash detection. So this is your supply and extract ductwork for the facility. As you can see, this here, what you're looking at here, is the actual clean room ceiling, and then this is all the mechanical that goes on above the clean room ceiling. So it's very congested. It takes a lot of design and a lot of rework and a lot of discussion with all stakeholders to ensure it works for everybody. You'll see here you have the individual isolator extracts here dotted around the compounding. So this is obviously above the compounding ceiling here, and they all extract through here, through the roof of the building. So that just gives you a view on the amount of coordination that needs to be done, I guess. In terms of, and actually, sorry, there's a photograph now of what you're looking at above the ceiling. So I spoke about the amount of space available above the ceiling. The benefit here was that, as you can see, each leg that is being supplied into a thermal housing, so these contain the HEPA filters, so each leg had its own attenuator, which meant it was extremely quiet, giving a high quality finish for the people that operate within the facility. Because you're moving a lot of air, and at the end of the day, air movement will cause noise. But as I say, we were achieving noise level readings of 32, 33 decibels, which is a little more than a whisper inside in the rooms here. So that's just it gives you an idea of what mechanical services went on above the ceiling to feed the room. And again, this is the 3D rendered image that the BIM model spits out as such. It gives you an idea of your entrance into the entrance lobby, into your first stage gowning, your second stage gowning, and into the compounding, etc. So it's easier for the client to view it as well and understand what space you've got. One of the big elements here was visibility through the facility, so that it's easy to see what's happening inside in the rooms without actually having to go into the rooms. So you'll see here there's a lot of vision panels dotted throughout the entire facility. But this is the office area here. And if you go to the next slide, you'll see, again, this is the office area, what was actually constructed. So you can see right through, from the office, through the prep room and into the compounding. You can see the isolators there in the background as well. So it gives the people working there good visibility throughout the entire facility. So from a quality plan, the initial stages, we keep reverting back to the URS, because during the project you'll do that as well. You keep going back as a reference point. So you review the URS, tender drawings and specification, technical submittals, workshops, design requirement documents, and BCAR submittals where applicable. Allow for discussion and discrepancies from the issue for information only to IFC. So this is where we're starting to discuss with the stakeholders, the design team, the clients, if there's issues or if there's anything that is not practical, if there's an alternative solution, etc. Here's where we start to trash them out. And it's important to leave relevant time for actually carrying that out. We move on then to mechanical ductwork layouts, reflective ceiling plans, etc. for the mechanical services. Likewise for the electrical services, and likewise for the clean room. And like I mentioned earlier, clash detection. And trust me, there was a lot of clash detection that needed to be trashed out, as you can see from the ductwork and all the services above the ceiling. To be fair, internally there was very little clash detection required, because there was a lot of planning done by the design team up front. Like I said, there was a lot of discussion with the client as well in terms of where pass-through hatches are located, where furniture is located, and that was of great help. So then we move on to agreeing what meetings are required. So you've BIM coordination meetings, drawing review meetings, finishes and samples such as benchmarks, physically looking at samples of the fabric that's going into the facility, and we were lucky enough in the scenario here whereby we were able to invite the design team, the pharmacy users, and all involved, the architects, etc., down to our facility in Cork, because we have a showroom there, so they were able to touch, they were able to feel the fabric, see what it was like, and it meant a lot rather than just looking at catalogue cutouts, essentially, you know. We also discussed program meetings and scheduling of same, customer visits in factories, such as I said, down to our facility in Cork to look at the showroom, but also to mechanical suppliers such as AHU suppliers, etc. BCAR meetings and safety meetings then from a point of view of how the guys are going to actually execute the project on the ground in a safe manner. The second stage then, so that's all the planning and what meetings are required. Second stage then, drawings for approval, product specifications for the cleanroom fabric, again likewise for the mechanical services and again for the electrical services. And then you get to the approval stage. So issued for approvals to the design client for comment and approval. RCP's wall elevations that we looked at earlier, they were all submitted in technical submittals, along with all the likes of the pass-through hatches, the likes of flooring, material, fabric, thermal HEPA filters, lights, etc. And safety and metadram sample issued to the safety guys on site for appraisal and if they require mock-ups, etc. And you move on then to the actual submissions that are approved, any clarifications required. Again, we had weekly meetings, which kind of spanned, I'd say, the guts of maybe 9 months, which to get to a point whereby everything was trashed out from a cleanroom submittal perspective, from mechanical and electrical. Then once all that good stuff is done, the install happens. So you have the installation verification, the installed material, and it's documented. So what we do is we have protocols generated for the installation verification, for the operational verification, and the performance verification. So you go from the installed, it's documented, moving on then once that's signed off onto your operational verification for the commissioning of the HVAC system. And I guess what's important to say here as well is, like, a lot of times you'll see P&IDs and people will commission and set your balancing, etc., to actual figures on paperwork. I suppose working with Connor and the guys on site here for Vincent's Hospital, it was, what we looked at was, yes, you have your design criteria, which you start off at, but then as you work through and you do your smoke visualizations and you do your recovery tests, you might find with smoke visualizations or balancing that you might find dead spots in some areas of the room, so you can adjust. So it's not a matter of just setting up the system to operate as per the P&IDs. It's a kind of a dynamic situation whereby you adjust as required to get the best performance out of the room. And moving on then, you start carrying out all your performance verification testing to the ISO standards, part 3. So just to give you an idea, look, on the technical submittals, we propose most suitable materials and arrange to meet the client requirements, typically in line with trusted suppliers and partners. So as I say, we partner up with Kingspan, and we have for many years now on the cleanroom system. So they provide the doors, the walls, etc., vision panels. So it's all from one supplier, and they have an extensive testing regime in terms of fogging and the hydrogen peroxide testing of the materials, and so they've done a lot of testing on that and have documentation to back it up. So we work well together, to be fair, and we have a lot of background information that is very relevant to the client when they start setting out their cleaning regimes as well on site. The necessary and relevant information highlighted and provide to the client for review and approval, and then change any revisions made as necessary. So in terms of Vincent's Hospital, the panel fabrics, floor track detail, this is the type of detail you have. So it's an adjustable floor track to cater for any indiscrepancies on the concrete slab. The vinyl basically folds up underneath the recess here, so it's very GMP. It's all, you wipe down from the top down, and it's all very cleanable and very little crevices. All the joints are siliconed, so it's quite user friendly. The cleanroom ceiling profile system that we use is a walk-on system, which is, again, it's flush top and bottom, so all you see is a silicone joint. What we tend to do in terms of on the Vincent's project to minimize any waste and time on site. On the ceiling panels, we got the factory to actually create the openings for all the thermal housings and create the openings for the light fittings, etc. So the panels arrived with this format here. So just from a point of view, it leads to less waste on site, which we're all for, and less time wasted on site as well. So it's just a leaner install process. Again, the walls, very similar to the ceilings. This is how they're laid out and how they're joined together. And so you end up with just a single silicone bead joint down between the two panels. And because Vincent's was very heavily serviced from an electrical perspective, it being a septic compounding suite, inside the office area, we utilize these chases here to get all the electrical services down to minimize any surface mounted dados, etc. So it's all concealed, and it can be within the space of the 60mm wall panel. So it's in terms of doors, again, as I said, they're all by the Kingspan and they all come as part of the system. So doors were flush. I'll just zoom in a little bit here. You can see the joint here between the door frame and the wall panel. So it's seamless. You just have a single joint. There's no clamp on frames for the doors or anything like that. It has its own integrated traffic light system, and the magnets are not surface mounted. The magnets are concealed. You'll see them just about here if you can see my cursor. So they're all within the door frame. And then from an interlocking perspective, we spoke about the coming from outside to inside. So where you come through a lobby, the doors are interlocked with each other to ensure that you have no clean path through to a classified area from a non-classified area. And as part of that, our door interlocking design, we used the contactless wave sensors to minimize contact surfaces, just to aid with any cross-contamination, etc. We operate a clean build protocol system. The main purpose of this is to keep the quality from the very get-go as such, and to get the guys who are actually installing sockets, turning the screws, nuts and bolts, to get them into the mind frame of what we're actually building here, that it's a facility for producing drugs for very sick people, that it's not just blocks and mortar. It's very important. So it's to set the standard and best practices needed for the operation and maintenance of a newly constructed cleanroom environment, to outline the procedures for the completion of activities once the main construction building is closed. The leading concern is to ensure that there's no migration of dust from the construction area into the main cleanroom production area once the construction bubbles are removed. And as I say, it's and our own guys, our own installers have been with us many years as well. They're not just contractors, so they understand what we're trying to achieve here. And look, you can't introduce quality at the end of a project. It has to be right through from start to finish. So this is a photograph of the prep room. We looked at the door earlier there and the interlocking. One thing to note here as well, with the design, all the trolleys and all the shelving, everything is removable to allow ease of cleaning. So you can see all these trolleys, you can just be wheeled out. So it means you can get to every part of the room and floors, which is far more beneficial than built-in cupboards that are harder to clean. So from the prep room, we're looking in the direction of the first stage change. So on the right would be your compounding room here through the windows, and on the left is the office that we looked through previously. So from a contractor project quality plan, we looked at the information that we got from the URS earlier. So this is how the flow basically works. So you go from the URS through to the functional design specification, schematics, etc., onto design, the detailed design, the CALs, P&IDs, drawings, specs, technical submittals, etc. Apologies, I jumped forward there. Onto design review, verification, and then onto installation. And the installation then basically leverages back to what was designed. So when we document this, we have a design criteria for all the fabrics and all the room dimensions, etc. on our installation verification. And we basically verify what's actually installed versus what was designed. Likewise, when you move on to the operational verification, I mentioned about testing, adjusting and balancing. So as you balance it, you need to adjust. And that all comes from the schematic where you had the original design specifications and flow rates, etc. onto the performance verification, third-party certification, and failure and robustness testing. Again, this is another, and I just like to thank Connor. We borrowed some of these presentations from Connor to show the flow as well, right through from the construction complete, right through to pre-commissioning, setting the equipment and setting up the work area, regulating, adjust and balance as required, onto the functional performance testing and dry run tests, onto site acceptance testing then. And this is really where we would complete most of our works, and then it's handed over to Connor to bring all that together from a point of view of us giving him performance verifications that are certified to the EN ISO 146, which is an ISO class 7, class 5 and class 8, for Connor to bring that together with the gowning regimes and SOPs, etc., to bring it to a grade A, B and C, etc. So from a business resilience point of view, all the HVAC systems were robustness tested. So we basically did blackouts, we shut systems down, we cut power to make sure the system did what it needed to do. We carried out cyclical testing on critical items such as interlocking on doors and pass-through hatches to ensure and give peace of mind to the client that they're not going to have any issues down the road. So we also perform a 24-hour response to the client if there's anything that they need assistance on or they have any urgent issues. We're at the end of the phone. Continuous business operation to show where fault directly impacts the product or human safety will allow a quick turnaround and resumption of business. And we provide critical spares as well. And we recommend to keep certain spares in stock so that to minimise downtime. So on the testing side of things, this is the sequence of testing we carried out. You've airflow volumes and velocity testing, room differential pressure testing, HEPA filter integrity testing, differential pressure gauge calibration tests, light and sound levels, temperature and relative humidity, airflow visualization and room recovery testing. Particle count analysis for non-viable, so these are purely non-viable testing. And I mentioned earlier about a schedule. So this is the schedule that we set out for commissioning, which takes you down through BMS commissioning, right through to the performance verification, which are the tests I just called out there earlier, and the sequence of how those tests are carried out, right through to the robustness testing that I mentioned, such as blackout, power blackout, shutting down, auto startup, etc., door interlock testing, and pass-through hatch testing. So it's pretty comprehensive, and it gives a clear picture of the sequence of how everything needs to happen as well. This part of the performance verification, I suppose the nuts and bolts of it is you need to get a certificate at the end of the day and say that the room is performing in terms of particle counting. So just to give you an idea for the compounding room, the allowance at 0.5 microns was 3,520 particles at 0.5. So you can see here what the actual results were. You had 55, 96, 55, 39, etc., etc. So the performance was very, very good. And this is the raw data with the wet signatures from our own test engineer, who are all CTCV trained, and then from the client point of view, which was with Conor Murray himself. Again, room recovery testing. This is a sample of the performance verification room recovery tests for the compounding room. So again, you can see here, sorry, it might be a little bit small, but I'll zoom in. at different test point locations. You got 6 minutes, 7, 6, 7, so on, so on. So 5 minutes there. So again, very, very impressive results, and the raw data that goes along with it. The room the room visualization, then we obviously carried out visualization and recorded it. So you can see here one of the engineers demonstrating in around the isolators to make sure that there's airflow throughout the entire room, around pass-through hatches. So you can see there's very good airflow happening there in around stabilizing dampers as well. So there's no dead spaces you can see, and it would show up immediately if you did have dead spaces there. As I say, a picture paints 1,000 words. And this is in behind the isolator as well, where it's quite confined, but again, you can see the air is moving quite freely through all those areas. And at the end of the day, this is what we present. It's the certificate of compliance for all the different rooms, the classifications required, etc., and what it achieved at the particle size. So these are the relevant standards. We work to the EU GMP for food and beverage, cosmetic, pharmaceutical products, dietary supplements, and medical device. And this is our own integrated management system to ensure that it's right first time approach to all our projects, and that we're committed to complying with customer, legal and other requirements. And I suppose the main thing is that we're not too proud to continually improve our processes and our SOPs as we see they need improving. We offer a service and maintenance repair of all types of environmental AHU, aircon, maintenance of lab equipment, fume hoods, etc. Building maintenance on mechanical and electrical systems, troubleshooting and fault finding. As I say, we have a lot of years of experience, so we have a good knowledge base down here in Clearsphere. Detailed maintenance, UV lighting, filter supply fitting and testing, PAT testing, etc. We also carry out HVAC commissioning, air and water balancing, etc. Fan filter units, fan coil units, pressure cascades, and detailed HVAC commissioning documentation. So on a continued compliance point of view, it's the ISO 14644 verification risk-based approach. From a maintenance verification, contract with clients, schedule testing intervals agreed, number of frequency of visits, as we would have done with St. Vincent's University Hospital. Not all testing is required at each visit, so the likes of HEPA filter testing, depending on the classification of the room, performed under at-rest conditions except for otherwise necessary in operation. Example of particle counting. So there may be operators in there, or there may not. And then the frequency, as I say, is factored on a risk-based approach. And that's just the testing frequency from a point of view of the classifications. So, thank you all. I hope I haven't bored you too much. And I'll open the floor if anybody has any queries or questions.
First of all, Colin, thank you very much. Great detail, very interesting actually, very interesting. I suppose the first thing we'll do, Colin, can you see the chat line?
Can you see my screen, Chris?
Yes, I can do, yeah. Right, yeah, not as good.
Perfect. Thanks a million. Hi, everybody. So my voice is a little croaky, so hopefully I'll be able to get through this presentation okay. But firstly, many thanks to Colin from Clearsphere for his presentation. We would often work with clients who would have utilised Clearsphere in terms of their choice of cleanroom provider. So it's very interesting to see the process that goes into actually building and installing the cleanroom before we arrive on site. So many thanks for that, Colin. So just a little bit about myself. My name is Barry Fitzgerald. I'm an account manager now with Ecolab, the Life Science Division, for 7 years now. So I cover a mix of both hospital and industry accounts in Ireland. So you're looking at mainly the east and the south of the country, predominantly industry, but a lot of the hospitals would be in that area also. And I'm living in Cork, married with 2 little girls, so Faye, who's 4, and Molly, who's 1. And they're great to keep you occupied after a day's work. And pastimes, any opportunity really to spend some family time and get outside is something I cherish a lot, really. Just a little bit about Ecolab before we begin. So we're an American multinational across 7 different divisions. So this will cover off food and beverage, healthcare, institutional, and pest. And obviously I would sit within the life science portfolio with a global reach. And our approach in life sciences really is to support from a contamination control and cleaning and disinfection process. So again, what's important here is cleaning and disinfection, that you're differentiating between the 2 terms. And just to support us as we work through the presentation, cleaning being the physical removal of soiling from an area. So you're not looking to achieve a level of kill, whereas with disinfection, you will achieve a kill. And then our solution, so again, we provide contamination control solutions, both in terms of chemistries and technical knowledge, and we also have bioquell technologies, which will support customers to make their processes safer by reducing risks to their process and facility. And again, obviously, regulatory expectations and compliance is of utmost importance. And within industry, cost savings would be one of the parameters that you'll be working through when supporting customers as well. Developing contamination control strategies would be part of what we do. We work in tandem with a technical consultant who is there to support any of the field sales people. So you're looking at assessing the current processes if it's an existing facility. You're identifying and documenting risks. This is through a physical visit to site. You're developing a strategy to mitigate and identifying risks. So again, it's another set of the current processes in place and bringing those to light if it's a risk, providing supporting documentation and validation. So again, a lot of the chemistries and products that we would provide to a site would have supporting documentation in terms of efficacy, mode of action, compatibility study. Again, if we think about the case study that we're speaking about today, you're looking at a hospital that has invested a lot of money in building a brand new facility, and you want to ensure that any application of any liquid or chemistry applied to a surface will not deteriorate or degrade that facility or be of harm to either operators or that facility. So again, the technical expertise, a site survey, or it can be a scaled down version by way of a technical visit. So these take place in terms of an in-depth on-site analysis of cleaning and disinfection processes, and are done to determine the compliance with good manufacturing practice and alignment with inspection expectations. So again, a lot of the technical consultants will have the expertise, possibly micro backgrounds, a lot of knowledge as to what auditors will look for when they come on site, and opportunities for improvement, for cost savings and complexity reduction. So you're not looking to reinvent the wheel. It's a matter of streamlining a disinfection program, maybe lining up small and large surface disinfection with the same chemistry, and various maybe formats of the same chemistry. We're looking at operator safety and environmental impact. So again, it seems to be a key priority within sites now, whereby environmental impact or sustainability is part of their agenda. So what can we do to support them with that? And risks of non-compliance with emerging standards. And again, probably more tailored towards industry accounts where you're looking at challenges that would occur if there is non-compliance within the site. So moving into the case study now, St. Vincent's University Hospital in Dublin. We looked at a set of objectives with the support of 3 dimension. So we were looking at an initial cleaning and disinfection program. We're also looking at supporting with a routine cleaning and disinfection program for ongoing cleaning and disinfection in the area. Transfer disinfection. So again, moving from a lower grade to a higher grade area, what steps would need to be considered and how we would approach that. Best practice wiping and mopping techniques. So again, what support we could give the team when it comes to wiping and mopping, which would follow application of the chemistry, and then training. So in this case with St. Vincent's, it was a third-party contract cleaner. So ensuring that they were confident and competent in terms of using the chemistry and using the application methods as well. So we started by reviewing a gap analysis. We looked at the existing cleaning and disinfection practices. We planned the implementation of a cleaning program for the new unit. So again, this might differ from other projects because it was an existing pharmacy unit where we had a relationship and products being used on site before they transitioned to the new unit. Then you look at compliance, so ensuring that the correct suite of products are used on site. Consistency, and what I mean by that is looking at, we'd say, spraying your application or spraying your chemistry onto a surface versus using an impregnated pouch wipe, for example. Obviously, there's a risk from a consistency viewpoint when you're spraying versus usage of an impregnated wipe. And then best practice. So what is the best application or the best method of working with these products within the environment? So these are just a couple of images of the old unit. So you're just looking into the prep room on the left and through the viewing panel into the compounding rooms. So again, the glass, the viewing areas, aesthetically, we would find the most difficult to clean surface. Over application of chemistry can often lead to beading of solution, which can often harbour residues. So again, that's not something that is nice to see, or if an auditor was viewing an area, it's not something that they would like to see in an area either. So you just need to be cognizant of that when you're looking at these areas. And here we're just looking at some of the pressure. So many different conversations. The grade C background area. And here we've got the prep room, just some of the operators working in the area. Again, nice flush surfaces, very clean area. But again, your viewing panels, which will be an area to consider when you're looking at the various chemistries to consider. Then when it came to looking at the approaches, there were 2 main approaches considered before deciding which one to proceed with. And the first one was a 9X application, which was 3 applications of a detergent, bacterial, sporicide over the course of a 3-week period. So again, this presented challenges in terms of additional delays when it was over a 3-week period. Or one of the other considerations was a vacuum clean followed by neutral detergent, a sporicidal application, which would also cover off your bactericide efficacy, and an RBDS, which is a rapid biodecontamination service carried out by our Bioquell division, who will cover that off in a presentation later. But what's interesting here is the neutral detergent application would be something that would be consistent with main application programs that would be used in other units. So again, your neutral detergent is a cleaner, So if you remember what I said earlier, you're not looking to prove any efficacy. It's usually used as a first step application after a deep clean or a quarterly clean. So maybe if guys were in servicing an area or a piece of equipment such as a HEPA filter, your first application will be a neutral detergent or a detergent of some sort. You're peeling away any residues, removing any physical soiling or dirt. So when it comes to the application of your sporicide or your bactericide, you're applying it directly onto, if you want to term it, a clean surface. Okay, so just moving into the proposal in a little bit more detail, the vacuum clean to remove any physical dirt of the area before you move on to a neutral detergent. Neutral detergent, mechanical action would have been involved here with the implementation of a clear wipe. So again, all soiling is removed, and it may have to be repeated so that all visual residues are removed. And again, this would be the case in most sites. A final residue removal step of denatured ethanol would then be performed, because denatured ethanol may leave a residue. At this point, baseline environmental monitoring surveys were performed to determine bioburden measures and identify the flora within the clean room. Then moving on to step 3, there was an application of low residue peroxide suggested. So this is a sporicidal product, so focusing on elimination of spores, a harsher chemistry than your denatured ethanol. But again, it's a peroxide product, so breaking down to oxygen and water. And it being low residue, it's one of our newer chemistries. So again, we didn't want to be suggesting or implementing a chemistry that would generate high residue, considering this is a brand new facility. So this was recommended with a 10-minute contact time. After the contact time, environmental monitoring to be carried out, and a review of the data, depending on results, possibility to repeat step 3 again. And then step 3, obviously focusing on the rapid biodecontamination service before the unit would be fully operational. This is just a schematic of the area. Quite a busy slide, but I have an easier one on the eye on this slide. So again, you've got the lobby area down here in the bottom right, moving into the first stage chain and then into the second stage change. You've got your preparation and compounding areas then, which are grade C and B. But what we took from this area really was the size of the areas. So you can see your compounding area at 56 meters squared and your prep area of 62 meters squared. We're really thinking there about the application methods of the chemistry for the large surfaces such as the floor. So again, this was telling us, giving us a good guideline in terms of what might be the best application method to suggest for the hospital here, and also the store, the office, the collection lobby, what type of areas will be there to store any possible chemistries or equipment. If there was large pieces of equipment, it may not be suited for the site. Then we moved on to the product mix. A busy slide, but if we just focus first of all on the green coloured lines, the rows, you'll see that they're clustered as denatured ethanol. So starting at the top there, you've got denatured ethanol. The top 2 lines, one is with deionized water, the other is with water for injection. The unit size is 500 millilitres. So this was something that we worked with because of our knowledge within other hospital ACUs. This product is available in 1 litre format and 5. But the feedback from other sites is due to repetitive strain injury with the weight of a 1 litre bottle, that the 500 millilitre format is a better option. So we suggested that, in addition to on line 4 there, you'll see denatured ethanol mop wipe. So the impregnated mop wipes were suggested for floors, walls and ceilings, which will be categorized under large surfaces. And then at the bottom 2 lines were impregnated tub wipes. So tub wipes suggested on the basis of driving consistency. And again, two types of tub wipes there. You'll see denatured ethanol 22 GSM, and below that denatured ethanol 42 GSM. So GSM refers to gram per square meter. It refers to the strength of the wipe. So what we did is we linked the application to the grade of the area. So the 22 GSM might have been used on the outer areas, maybe your CNC, your controlled non-classified, or your grade D areas, and 42 GSM then maybe moving into your grade C areas. And then the neutral detergent up on line 3. Again, it's in a mop wipe format, and the dark grey lines on line 6 and line 10 is low residue peroxide mop and pouch wipe. So again, it's the same chemistry but just in different format. And again, our mop wipe for large surface disinfection, and the pouch wipe for small surface disinfection as well. Just over on the right there, two bubbles with key points to consider. Spraying is less consistent than impregnated wipes, which is a key point to consider. So again, if you have an operator coming in, they're spraying denatured ethanol, unless it's defined in the SOP, how many sprays. So if you think of them spraying a dry wipe, how many sprays on the dry wipe? Is it considered wet? Is it still too dry? What areas of the dry wipe should they be spraying? Versus just pulling a wet wipe from a pouch wipe where it's already impregnated. So it reduces any risk that it's not sufficiently wet with chemistry. And then looking at reducing due to less product usage. So again, with your impregnated wipes, you're achieving that environmental reduction as well. So this schematic was important for us to design as well, because it looks at the direction that you would conduct your cleaning within the area. So if we look at the compounding suite, you're looking at moving from back to front, and this would align with the principles of wiping and mopping, where you're looking at moving from top to bottom, back to front, and cleanest to dirtiest at all times. So if you look at each room that has an arrow in it, even in room 7 here, the ACU office, you're going towards the door, so you're working out of the room. So you would not want a situation whereby you're going the other way and you find that you're after cornering yourself in the room, and you may have to then step on the floor to get back out of the room, at which point you would then have to reapply the disinfectant because you will have stepped on the surface at that point. Then we moved into frequency of application of the disinfectants, and this was in the compounding room and the second stage change room. And you're looking here at your large surfaces. So when we speak about large surfaces, walls and ceilings. So what we did here was, starting with ceilings, the frequency was quarterly, so once a quarter. Glazing in the walls was monthly. Glazing on the doors was weekly. Walls was weekly, and floors daily. Obviously, floors, highly trafficked areas, in addition to any particles falling onto the surface, would be a daily requirement for disinfection. And then you're looking at the smaller areas within the compounding and second stage. So you're looking at your isolators, your doors, door handles, presses, cabinets, benches, worktops, step over benches, all of those. So again, you're looking at mainly, with the exception of your gowning racks and the cabinets as well. Then moving on to the prep room, the ACU store and the first stage change, large surfaces. Again, ceiling 6 monthly, the least frequent area. Glazings in the wall, monthly. Doors, monthly. Walls, monthly. And then your floors were weekly and monthly as well. And again, your disinfection agent here, when we say primary, it's denatured ethanol is what we're mentioning here. Secondary would be the spore side application again. Then you're looking at your small surface disinfection within your prep room, ACU store, and the first stage change. And again, it's in line with what we looked at in the other areas on small surfaces. So again, broken down into daily, weekly, and monthly, with it mainly focused on daily disinfection. Again, when you think within the clean room of who the biggest potential contaminant is, it's us as humans. If you think of everything we touch, if you're working at a bench or a worktop station area, contamination can quite possibly spread rapidly if it's not on a routine basis. Then we moved into training, and what was important here is we were cognizant of the fact that, first of all, it was a contract cleaning company that was going to be employed to conduct the cleaning and disinfection of the area. And second of all, maybe some of the products, both the chemistry and the format, might be new to them. So we wanted to ensure that they had full confidence in the use of it and an understanding of how best to handle the chemistry as well. So what we wanted to do was understand the cleaning and disinfection in a clean room environment and the need to prevent microbial cross-contamination. Obviously, cleaning at the best times can be a little bit mundane, so it's about educating the team as to the importance of conducting cleaning and arming them with the knowledge. And then if they understand why it's important to clean, that a more methodical application will be done. So correct handling of disinfectants during preparation and use. A little about the basic microbiology and understanding why contamination control is important, and the critical point being here patient safety. A lot of the patients have immune compromised issues in the wards where the chemo is manufactured. It's important that it's done so in a controlled area. The correct application techniques for cleaning and disinfection, including mopping and wiping. So we'll just look at those in a sec. And training should incorporate some practical demonstration of application techniques, including wiping, transfer disinfection, mopping, and assessment of competence. And we supported the team with that, with physical visits to site, where we did some hands-on training of the wiping and mopping application. So this is just a short video on small surface wiping. Okay, so that just went through some of the principles that we would have educated some of the cleaning team on. But one of the important considerations as well in choosing the impregnated wipes over the trigger sprays was particle atomization as well, especially for within use within the isolators, where the low residue peroxide pouch wipe was implemented rather than a trigger spray, which would possibly in the isolator, but also for operators for small work surfaces, considering it was a peroxide-based product. So just moving on to large surface disinfection, and there should be just a short video on this one as well. Okay, and you can see from that video the importance of having any sockets flush with the walls or surfaces. And it was something Colin showed in his presentation. You can see there the additional workload when it's not flush. You have to come back with a wipe and manually go around each socket and switch. So just on some additional training that we conducted with the team, wiping, which is important, again, folding of wipe, ensuring that it's followed within the SOP, how many folds per wipe, and that's important because the more folds you have with a wipe, the higher the risk is that you're going to have cross-contamination due to potentially human error, where essentially you may forget which side you folded and then reapply some contaminated part of the wipe back over a surface unintentionally. And then you look at some of the technique there called the pull and lift technique, whereby you're pulling contamination and lifting, so you're removing the contamination from the surface rather than potentially just pulling the contamination to the edge of the surface and it falls to the floor. So you'd be potentially just moving contamination from one surface to another. Okay, so just to summarize, we supported 3Dimension and St. Vincent's University Hospital initially with a site visit through our technical team. So Jane Forbes was the lady who supported me with the site visit. We looked at compliance and best practice. We developed a proposal which met the needs of the client. We then had delivery and implementation, training with the users of the product and the equipment. And this all prepared for our automated disinfection step, which was conducted by Bioquell with their RBDS service, which Mike Wood and Kirsten McKeown are going to touch on in their presentation a little bit later. So that's my presentation, folks. So anybody, any questions?
Yes, we can see that, Mike. Yeah.
Perfect. So, hi everyone. As Chris and Barry, I have been part of the family for about 9 years now. It was originally Bioquell and Ecolab acquired us in 2019. We've completed our integration into the company and we are now under the one umbrella, which is known as Ecolab. So following on from Barry's presentation, to give you an insight into Bioquell's Ecolab's rapid biodecontamination services and what we did in the hospital. We'll give you an idea and a flavour of what we do first. So what is it and what do you get? You get decontamination of any given enclosure, provided it can be sealed. Now, when we say sealed, we do not mean hermetically sealed. We can do a single room to an entire building. Contamination, so it's verifiable 10 to the 6, spore reduction, so above 6 log. It's got broad efficacy spectrum. It's residue free and it is hydrogen peroxide. So it's 35% aqueous hydrogen peroxide flashing. The service itself is self-contained, including all consumables. It's flexible to fit your requirements.
Hello, Michael.
Hi.
I'm sorry to disturb your presentation, but we cannot see the presentation right now. Can you start screen sharing again and please share the whole screen and then open the presentation, please.
Can you see that?
Yes, we can see it now.
Okay. So, sure it's going through. So, 1 second. I've moved 2 slides and are they showing as I'm on slide 3?
Right now we only see the first page.
Yeah. We have to come out of this. Go back in again. 1 second. Yeah. So can you tell me if any of those slides have changed for you?
Yes, I can see the third slide right now.
Okay. I can't do it on full screen, so I'm going to have to do it manually. Okay. Back to the service. So what is the service? The service itself is self-contained, including all consumables. It's flexible to fit your requirements, including timescales and operating procedures. And there is no need for capital equipment purchase we bring everything, the engineers, the consumables, and the equipment. So, St. Vincent's University Hospital migrated and transferred existing aseptic compounding operations to a new pharmacy aseptic compounding unit. The cleaning and disinfection of the new ACU in terms of both clinical clean as part of startup and ongoing compliance with EU good manufacturing practice. Solution: the BioQual Rapid Biodecontamination Service, or BDS, was chosen to perform a 6-log kill sporicidal reduction with automated hydrogen peroxide vapor decontamination for the new pharmacy. Within the enclosure, we use of our Claris or generators. The area was 457 meters cubed. We use 65 BIs and CIs, so chemical indicators, and the BIs are the Geobacillus steratomophilus endospore. 100% success rate, and we deactivated them all. 100% pass rate, and a decontamination completed on schedule in 1 day. So what does it look like? Step 1. Sorry, go back. So step 1, BioQual decontamination systems warm up. That's when we glue 35% onto a flash evaporation plate and start to pump it in. Step 2 is the system emits the vapor into the enclosure and fills the space, pushing the vapor against exposed surfaces, including surrounding complex shapes and crevices. So every nook and cranny, the vapor will get into it. Step: once we have completely filled the area with the vapor, we go into what's called our dwell. So our dwell can be anything from 15 minutes to half an hour, and that's where we achieve our full kill. And step 4 is aeration. So aeration is where it's a catalytic conversion oxide back into oxygen and water vapor. Once we have the facility down to 0.0 parts per million, our engineers gown up, re-enter the room, retrieve the equipment, and hand the facility back to the microbiologist. So what is the equipment? As I said, this is a Claris or vapor generator. It is located within the enclosure. It weighs 20 kgs. It is built like this so that 2 engineers can catch either side of the unit, holding a handrail and walking up a flight of stairs. They are built to do 250 meters cubed, with the volume 50 meters cubed each. However, we can infinitely daisy chain these together, so we can hook as many of these systems together as we want, make them all speak back to a central control panel outside the target envelope. They're easy to transport and maneuver, and they're self-sterilizing. This is a BQ50 aeration unit, again mobile. Aeration units rapidly convert hydrogen peroxide vapor into water vapor and oxygen. They're efficient and quick for removal of vapor during the final stage. Again, they leave no residue and no further cleanup is required after the deployment. So what did St. Vincent's look like? This is a map showing all of the Clarises in situ, all of the BIs and CIs that were placed within the enclosure, all of the aeration units, and the comms cable that was used to connect all 6 units back to the control panel. The parameters for this, it was very, very straightforward. 10-minute conditioning time. What our conditioning time is when our Claris or vapor generators are coming up to heat. So we're raising the heat. Once they reach heat, we went into our gassing stage. It took 37 minutes. The dwell time, where we achieve our full kill, was 20 minutes, and aeration took 125 minutes. The amount of H2O2 injected was 4,216 grams. Thanks to Collar, he passed some of these pictures on. These are pictures of the inside of the target area. We also decontaminated the isolator. The isolator was open, and this was done so that in case of cross-contamination. So when the isolator was open, if there was anything there, we would migrate it back into the room. So, newly constructed pharmacy aseptic compounding unit, ACU Ireland. So the entire target area is 457 meters cubed. BioQual RBS was selected as minimal production downtime was needed without purchasing of capital equipment. Sensors were placed in various different areas to record the full parameters of the cycle, so parts per million, relative humidity. Biocide and peroxide vapor generators were positioned at 6 locations, as was shown on slide 7. So why use RBDS? Worldwide service, so it's a single solution for all global sites. No capital outlay required. The service is performed on scale, so out of hours, weekend working, post shutdown. We look to minimize your downtime. We have tailored deployment models, so emergency call out, regular decontamination schedules. We have validated cycle development. We had implanted RBDS site engineers, so this is where one of our engineers would work for one of our clients, spending 5 days a week on that site and just decontaminating rooms or areas. We also offer a 24-hour response contract, so recovery contingency planning service, and we guarantee 100% BID activation. If we do not achieve 100% BID activation, we will come back and redo the deployment for free. It's fully verified and documented decontamination service and significant time savings on traditional methods. And that's my side of the slide. Next will be John Tune, Scientific and Regulatory Director for Ecolab. And if anyone has any questions.
Thanks, Mike. I'll take over from here. As Mike said, I'm John Tunes. I'm Bioquell's Director of Scientific and Regulatory Affairs. I've been with Bioquell for over 20 years now.
Is that back up there, John?
It is, yeah, thank you. No and so I'll just ask Mike if you transition when I ask. And as I said, I've worked for Bioquell for 20 years and look after Bioquell's global regulatory position. I'm the Deputy Chairman of the British Standard Institute CH216 committee that writes the disinfectant standards, and I'm also the Chairman of the European Task Force that writes efficacy standards for automated airborne disinfection systems. And what I wanted to talk to you about today on the back of the decontamination of and the RBDS service is basically the regulatory position of biocides and biocidal products within Europe, because one of the things that we've found in Bioquell is that there's kind of a paucity of knowledge and understanding of the regulatory requirements on disinfectants and particularly automated airborne disinfection systems. Mike, if you'd like to move to the next slide, please. And so disinfectants are regulated by a regulation within Europe called the Biocidal Product Regulation. And this regulation came into force in 2013 and applies to any product that is used to mitigate, kill a microbiological organism. And the aim of the regulation is basically to minimize the harm to the environment and to operators who are using those disinfectants. And so the regulation basically requires manufacturers of disinfectant products, biocides, to submit dossiers supporting that. These dossiers are then scrutinized by regulatory authorities, and approvals are given or not into how these disinfectants and biocidal products can be used and whether they can be used on the market. Mike, if you'd like to transition. Thanks. And so when these dossiers are put in, they can actually have different authorizations. And so there is something called a union authorization, which is the widest scope authorization, whereby a company that obtains a union authorization can then sell their biocidal product, their disinfectants, across the whole of the European Union. Alternatively, companies who may only, for example, want to sell in Ireland can apply for a national authorization for Ireland, and if they obtain that authorization and then allowed to sell that product on the Irish market. they're only allowed to sell that product on the Irish market. If they were to sell that product in France, for example, that would be an illegal use. It would have been an illegal operation, and the regulators in the country would come in look at that sale. And the other thing that someone can do is something called national authorization with mutual recognition. And this is where if someone wanted to sell, for example, in Ireland, France, in Germany, they could apply to the Irish authorities for an approval. And then if they got that approval, have mutual recognition in France and Germany. Now, from Bioqual's perspective, for our product, our 35% hydrogen peroxide product, our generators, as Mike described with the RBDS, we submitted an application for a union authorization that went in January 2017. And Bioqual, it took 5.5 years. Well, it's still going at the moment, but basically, Bioqual received what's called a Bar Committee approval opinion in October last year for our product. And we're just waiting now for that to actually be ratified within European law, so that approval case. And this is something that people, I think, don't understand when it comes to biocidal products, is that these products are actually governed in law. And so when we look at Bioqual's product, it will be signed off by Ursula von der Leyen to actually say in law that this product can be used and how this product can be used. Mike, if you'd like to transition. And so biocides are broken down into something called PTs, which are product types. And there are 22 different product types. You can just about see them on the slide there. And for Bioqual, and for probably most of the people on this call, the most important biocidal product type is PT2, which covers disinfectants which are intended, not intended for direct applications of humans and animals. So that's any disinfectant that's used in a hospital, in a pharmacy clean room, in an isolator. All of these come under PT2. Bioqual also has a authorization to be used in PT3, which is a veterinary hygiene area, and Bioqual is very specific in relation to that, and I'll come on to that, and also in food and feed areas. Mike, if you'd like to transition. And so you can see in some of these pictures just references to those area. For Bioqual, with its PT3 use, we have what's called a restricted use. We don't want to use our product to decontaminate pigsties or chicken coops. However, our product is used to decontaminate kind of animal cages within biomedical facilities. And we are seeing, because of cell and gene therapies, more and more animal models being used. And so Bioqual's technology can be used within those very specific veterinary applications. And also, obviously, for a PT4, this is food manufacturing facilities, filling lines for food products, restaurants, restaurant table surfaces, etc., all come under PT4, which is where Bioqual's product can be used. If you'd like to transition, Mike. And so Bioqual's product and automated airborne disinfection products are regulated or under the BPR and require efficacy data standards. And so the standard that automated airborne disinfection technologies such as Bioqual's are held to is a standard called EN 17272. And in this standard, you actually test the generator in a real world type enclosure. And actually the picture is very small there, but you can see the enclosure in which we actually did our testing there. That's a 78 meter cubed enclosure. And what happens within the test is that carriers containing microbiological organisms, and depending on the claims that you want to make for your technology, depends upon the types of organisms that are placed out in the locations. And they're placed at a distance facing away from the generator. You then run your cycle and you look at the recovery mechanisms, and specific log reductions have to be achieved. And a second part of the test is that carriers are placed within the corners of the enclosure. Carriers contain Staphylococcus aureus, and a 5 log reduction of Staphylococcus aureus must be achieved on all of those carriers to show that you actually get distribution throughout the enclosure, and you can achieve the kill in those corners of the enclosure. So Mike, if you'd like to transition to the next slide, please. And unfortunately, you cannot see it very well there. Shows the different organisms that are required to be tested against to make the different claims for the technology. And if you haven't tested against those organisms, you cannot make those claims within your submission dossier, which means that you cannot then claim to use that product and have an authorization for that product. And so you can see here, if you wanted to claim a product to be bactericidal, you've got to test against Pseudomonas, Staphylococcus, Enterococcus, E. coli, and Acinetobacter for the different areas here. And you can see different areas such as medical area, veterinary area, food and industrial area require different levels of log reduction. And what the figures are showing there is, if I look, for example, of the Staphylococcus aureus, it's a 6 log loading onto the token, which then requires a 5 log reduction to achieve a pass. And so you need to achieve a pass against all of these organisms to be able to claim that activity. And so BioQuell's product, we've tested all of these organisms, and within our union authorization, we can make claims to be bactericidal, sporicidal, fungicidal, virucidal, mycobactericidal, and phagocidal. And one of the things that people need to be aware of with their disinfectants that they're using within their facilities is actually the microbicidal actions that their products are authorized to be used for. For example, if you have a product with a bactericidal claim, that cannot be used against viruses. It's not an authorized use, it's an illegal use. And so you have to have a virucidal product to be able to use it against viruses. For example, a sporicidal product to be able to use it against spores. Mike, if you'd like to transition. And just because that, as I've been talking, is the European BPR. Due to Brexit, we now also have GB BPR. So when the United Kingdom was part of Europe, we were under EU BPR. We now have our own GB BPR, of which dossiers had to be submitted by last year to allow products to remain on the market in the UK. And these dossiers reviewed by the Health and Safety Executive. You can see there, just as an example, just of costs. Just a submission dossier is somewhere between £25,000 and £35,000. For BioQuell's European dossier, we're probably up to around about £500,000 at this moment in time. For the cost of actually obtaining registration for the products. And what BioQuell will be doing, we've submitted the identical position in the UK as we have for Europe. And so as the process goes through, BioQuell anticipates to have an approval opinion from the HSE as well. Mike, if you'd like to transition. Can you transition to the next slide, please, Mike? And Mike's not there. And so basically, the next slide is just going over the key points and things that people should be asking really when it comes to disinfectants and use of disinfectants within their facilities. They should be asking what product types is the disinfectant authorized to be used for, and basically BioCore has the validated cycles, and we have a vapor phase. One of the key things that people need to understand, and I've said it, is that the EU BPR regulation is law. It's a law that must be complied with, and it's not purely on manufacturers like BioCore placing the product on the market. If we were to sell a product for a use that was not authorized, that would be an illegal use. But it's also applicable to the users of products. If someone takes a biocidal, takes a product that's not authorized for biocidal use and uses it as a biocide, that's an illegal use. And obviously there are consequences from the point of view of actually having illegal uses. And so people need to understand this. And as I said at the opening, I don't believe, from my own experience of talking to people within industry, that industry fully understands the implications of the BPR yet, one on chemistries that may disappear or not be approved, but also upon the chemistries that are currently being used by people to understand whether they will have the authorizations to continue to be used in the way that they are. And if they don't, the implications for the users of those chemistries from a legal perspective. So I hope that was interesting. I know it was slightly different probably to what people were expecting in relation to this, but it's just to give people an understanding of the BPR. And if anyone has any questions, be happy to answer them. And thank you, Mike, for doing the transition.
Yeah. So, are you planning to upgrade your Pharmacy ACU? 78% said yes, 22% said no. That's interesting. The other one then is, do you use this closed system transfer devices for chemo compounding? Again, 78% yes, 22% no. So interesting results there. And if you do work in support of hospital pharmacy ACU, what primary engineering controls do you have in terms of clean air equipment? 30% said isolators, 10% class 2 BSCs, isolators for civils, 20%, and cleanroom 2 for civils, 20%. So again, interesting results. So what I think we'll do, if there's no questions, I think what we'll do is we'll just take a quick 15-minute break.
Hi, Yuka.
Hello, can you hear me?
Yes, I can hear you. Yes, that's great.
Okay, guys, welcome back. Welcome back. Yeah, hear me, yeah. So, one more speaker. Okay, so what I'm going to do, Lenny,
Yep.
maybe you just introduce yourself, as this is a joint ICA Nordic.
Yeah, I'll do that.
Yeah, so,
Okay,
and then
thank
you
you.
can introduce them.
Yeah, thank you. Sorry for my delay, but I had some technical problems with getting in and getting the camera. But now I'm here, and I'm here as chairperson for the R3 Nordic, which is the Nordic Cleanroom Association, which includes Finland, Sweden, Norway, and Denmark. Our organization is more than 50 years old and covers activities in cleanliness and clean rooms, and that's why we call it R3 for the 3 R's in Renhed and Rena Rum, which are the Nordic words for this. We have approximately 500 members in around from the 4 countries, and we are organized with a traditional way with a board with members from all 4 countries, and we have local units taking care of activities in a specific countries. So it was a little bit about R3 Nordic, and Jukka Vasara is here as member of R3 Nordic. And I don't know if I should introduce Jukka now or we need people to come back.
No, I think everybody is back, Nafsida. I think nobody else.
We can go on.
Yeah, so I think we move on.
Yes.
And again, Lenny, thank you very much for your introduction.
Thank you.
R3 Nordics is one of the oldest societies, and very active. So again, and thanks, and it was a pleasure for the ICS and yourselves to work together on this. So Jukka, it's all over to you. So if you want to introduce yourself, and then all I would say again, guys, is that when Jukka is doing his presentation, if there's any questions, feel free to put them on the chat line, and we'll pick them up at the end of this. Okay? Thank you very much.
Okay, thank you. Can you see my presentation?
Yes, we can, yeah.
Okay, fine.
We just move one slide and we just make sure it's moving because...
Yeah. So, so short about me, I'm Vice President of Granult Group, and my responsibility in Granult is to direct and coordinate Granult's hospital and clean room businesses, also innovation work. And what I have done in hospital sector, more than 30 years, project management in dozens of hospitals, more than 10 hospitals where I've been involved, and I'm also Finland's representative in the European standardization working group, ventilation in hospital. And also I have made quite a lot of clean room design projects in Finland and also in many other countries, for example in UK, China, India, Russia, among others. But what is Granlund? We have more than 1,200 experts, and here you can see what kind of design and manager work we are doing. I'm not going them through. About hospital sector, we have about 200 designers focused in hospital design, and during 60 years of Granult history, we have designed more than 2.5 million square meters of designed hospital spaces. And what is special in Granlund, depending quite many other designing and consulting offices, we put quite big effort for innovation work. For example, last year we put about 6 million euros to innovation projects. And some projects what we have done, for example, Helsinki University Hospital, biggest trauma hospital in Finland, and most important, it's coming ready just this month and going to take use in autumn. Children's Hospital, very famous also in Helsinki, is been ready a couple of years. Then in central part of Finland, central Finland's hospital in Jyväskylä, there is the biggest greenfield hospital in last recent years in Finland. And also, for example, eastern part of Finland, Kuopio University Hospital. Then at this moment we are quite big effort with designing Oulu University Hospital, which is huge project altogether, and for that area I'll show example of BIM modeling what we are doing. No sound, sorry. But anyhow, you can see here how the hospital, this is building A from this Oulu University Hospital, how it's going to be and built. And here is now the mechanical and electrical facilities what we have designed in the BIM model. And in this hospital, the clean room air handling units are in the center of this picture now in third floor, and under it is the operating theater department. So there are 16 operating theaters in this building and 60 in building B. So altogether 32 operating rooms. And as you can see, quite much piping work there. But to the main thing about my presentation. So if we think about GMP facilities in hospital, the main facilities are normal hospital pharmacies, because they make their medicines, and for that reason they must follow the GMP guidelines, and the most important parts of GMP concerning clean room design are chapter 3 there, premises and equipment, and of course annex 1, manufacture of sterile medicinal products. And I think that these are quite familiar to you, the main figures where we must go in different levels of CMB. Normally in pharmacy, hospital pharmacies, they are the most cleanest areas are B rooms, and then there is laminar cabinets which are grade A. And of course there are also the limits about microbiological contamination figures, and in grade A there is none of colony forming units. But when we start designing hospital pharmacy or other GMP facilities, normally the design process begins by drafting a basis of design document, and this document helps architects to allocate appropriate spaces for all processes, operations, and develop logical plant layouts. And document normally describes the operations that will take place in the clean room, such as the volume of production, personnel flows, material flows, large machinery, and preliminary options for structural and technical solutions. And here is for example, material flow diagram from basis of design document. And this document is drawn normally in cooperation between the pharmacy personnel and designers. And the basis of design document gives a good and firm foundation for continuing the designing of the facilities. And it's very important that the facilities are designed around process needs. Premises must be located, designed, constructed, adapted, and maintained to suit the operation to be carried out. And normally the aim is to minimize the risk of errors and cross-contamination, permit effective cleaning and maintenance, minimize build up of dirt, and also eliminate any adverse effect on the quality of products. About premises, normally clean room is a room within a room. It's tightly controlled environment, and typically room height in hospital pharmacy clean rooms is 2.6 meters inside. A space for technical equipment and maintenance above the clean room is usually quite big. The range is 2.5 meters for ductwork and ventilation and other technical installations which are placed in this space area. And normally we don't perhaps get those, for example, 2.5 meters, which is quite good height of that area. And it's very important in design phase to show that what height is enough that we can have the maintenance work done properly in this area. Premises should be laid out in logical order corresponding to sequence of the operations and the requisite cleanliness levels. And facility layout should provide short and logical roads for personal and material flow and avoid cross flows. And airlocks should be used to separate clean room processes from corridors and adjacent rooms. And also space reservation for special equipment in production area must also be taken into account in the design phase. Then some points from general guidelines. Rest and refreshment rooms should be separate from manufacturing and control areas. Sometimes toilets are put in the first corridor, but perhaps better thing is to put it totally outside of the clean room area. Separate waiting rooms, good size of storages, separation for quarantined, released and reactive materials. All production areas should be well lit and also effectively ventilated. And here are some examples about grade D and grade C areas of clean room hospital pharmacy. Structures in hospital pharmacies are preliminary designed by using sandwich elements. We use normally polyurethane elements which are coated with galvanized steel. Thickness of these elements are usually 65 millimeters or a little more. And this element structure should form airtight shell totally. Neither the cleanroom standard or GMP defines a specific material or way of construction that should be used for manufacture or elements and structures. There are only guidelines and the walls, floors, they must design for easy cleaning and resistant to cleaning chemicals. But it's possible to different kind of wall systems and materials to handle it, but it's discussion with end users what kind of clean room elements it's used in its cases. Covered floor and wall corners makes cleaning easier. Pipework, lighting fittings, ventilation points and other services should be accessible from outside of the clean room areas, and drains should be of adequate size, designed and equipped to prevent backflow. And in B-class areas there can't be any drains. Horizontal surfaces where dust can accumulate are tried to avoid. For example, these examples there are situated so that it's easy to clean and there is normally not any dust. Materials are selected for suitable for its facility. And then technical systems, ventilation, electrical supply, temperature, humidity and lighting should be appropriate and such that they do not adversely affect directly or indirectly either the pharmaceutical product during the manufacture and storage. Ventilation is normally implemented by using separate air handling unit and ventilation system which serves only the clean room area. And in hazardous air, if we have BCL2 or 3, then the extract air from laminar airflow cabinets is let outside by using separate ductwork and roof fan. And if necessary, according to risk analysis, the air handling units can be duplicated so that one is operating and one is reserve. And if there is maintenance or something failure in the unit, then it changes automatically to the reserve system. Pipes, drains should be easy to clean. Air exchange rates are normally between 15 to 50 air changes per hour in rooms. So in B areas are the most biggest air change rate. And supply air is brought to the room through ceiling diffusers which are equipped with HEPA filters. And the extract air is removed from the room by floor level extract grills on the walls. Normally circulation air rate is about 80 to 90% of supply air, but if there is for example BSL areas, then no recirculation air, so all must be fresh air. And normally we must humidify the air in winter time and dehumidify it in summertime. And the average about humidity level is normally 45% plus minus 10, and temperature about 21 or 20 plus minus 1. Of course, depending what processes there are. So here are some values and how they can differ in different kind of rooms. And normally these are discussed with the end users, what the process is. Normally it comes from the process. And if requirements are process critical, then should be clearly defined. They should be clearly defined. The requirements can in some circumstances be allowed to slip, for example the summer hottest days, and it's very important to discuss with end users is it possible that these limits goes up or down, or should be in every case between them. Pressure differences in different classes according to GMPs is normally 10 to 15 Pascal, and airlocks and gowning rooms are normally negative pressured compared to process rooms, and positive pressured compared to non-classified corridors. But then if there are some hazardous processes, then the process rooms must be negative pressurized to surrounding areas, and those are then quite difficult to design so that all pressurized between different areas are handled correctly. We have made about 10 hospital pharmacies in recent years, and all these in recent years have been made so that there is a control system for regulating pressure differences. Then monitoring system here is an example of picture how in one hospital pharmacy particles, temperature, humidity and pressure differences are monitored, and also where the alarm and sounding systems are situated, so that the people who are working there can know that all is in order, so that it's safe it's safe to work there. The pressure control system consists of VAV dampers, so variable air volume dampers, room control panels and control centers. And these VAV dampers regulate the airflow so that the room pressure remains in its set point. And this is quite critical system in CMP facilities, because there are many different areas with these pressure differences, and when we control and monitor that they are in time use, and if not, then the process must stop. So if there is some kind of failures in this control system, it straight makes very difficult to work there anymore. Clean room doors are often interlocked to ensure that only one door at a time can be opened from a single room. It's possible also to make it by traffic lights, but normally interlock system is more sure for conditions. So when door is opened, the pressure difference control is frozen for a specific period of time, and access to clean room area must be tightly controlled. Then this monitoring system, clean room compliance with its given requirements must be demonstrated by regular measurements and documentation. And recently it has become customary to produce documentation of compliance with a validated environmental monitoring system. And this monitoring system is totally different than the building automation system, what controls the air volumes and pressures, this only monitor and collects the data from pressure differences, particle counts, temperature and humidity. And normally the system consists of room sensors and particle counters. Here is some examples about those points. For example, here the pressure sensors, they are generally positioned to the ceiling. And then temperature and humidity sensors, they are normally located to the clean room wall, for example 1.5 meters from the floor. And then this continuous particle monitoring system, in grade A, it should be monitored continuously using dedicated particle measurement points. In grade B, which is the surrounding room, grade A laminar flow cabinets, there should be monitored continuously using dedicated particle measuring points. Other B grade areas should also be monitored. Grade C areas should be monitored to demonstrate that they are in control, and grade D areas normally there is no need to monitoring unless the end users want to have them there also. And the particle counter should simultaneously count and measure 1.5 micrometer and find 5.0, so small and big particles. And normally these particle pumps is located outside of the clean room because it's quite noisy. And the critical areas for sampling points are identified based on a formal risk analysis study. Here is an example of grade A sampling probe. It must be oriented in direction of unidirectional airflow and also be located above the critical area, demonstrating that the air above the product is absolutely clean. And here is an example of grade B sample points, which are positioned 1.3, 1.6 meters from the floor, not in corners or near the doors, and probe oriented in direction of airflow. And other grade B and C areas, the monitoring points activities, they are determined using risk analysis. And here is some photos from the collection system of different rooms. Then some words about validation, but I'm not using much time about this because I think that it's quite clear to everybody. But anyhow, validation is done by measurements, tests, and experiments. And the documentation is vital part of validation. Validation in hospital pharmacies covers the clean room, its technical systems, and the processes to be carried out in. Normally, when we are designed the hospital pharmacy, we also take part to the technical systems validation, so we can do it to the client, and if needed, we can also help with the process validation work. Then at the end of my presentation, I show one example. This is from Lapland Central Hospital in Rovaniemi. It's now they are building it. Our design phase is mainly done. There is also quite big hospital pharmacy, and now I show you from the hospital pharmacy BIM model, so you can see how we showed our design work to the end users. So here you can see that there is areas around the cleanroom area. So the gray area, and also this walkable ceiling area. And now we are going inside the personal airlock, where people change their normal clothes to clean room dressings. And after there, to clean corridor area, where you can go to different process rooms, and there are also pass-through boxes to those which are situated in the floor level, so you can put there those tables with rolls, wheels. And here is C-class laboratory, and as you can see here, all furniture are stainless steel. And now we go ahead. C-class airlock, and changing clothes there, and then to B-class process room. And these cabinets are then A-class. And here you can see also the traffic light, so people can see that everything is okay there, that it's safe to work there. And with this kind of building model, it's easy to discuss. Normally, when we show this, then the end user says, no, not this. I want to have this little bit different. So it helps a lot of that. We can make the changes in the design phase, not in construction phase. But here is what I thought to show you. If you have any questions, I'm happy to try to answer to those.
Thank you, Jocke, for a very detailed, good presentation. I'm just checking if there's anything on the chat line here. Not at the moment, but if people have any questions, please feel free to ask.
Yeah, well done, Jocke.
Any questions from any of the presentations today? Okay, I think then with that we can wrap up. So I don't think there's anything else, Conor.
Yeah, well,
we have a question.
Okay. Hi, Why did you build a B cleanroom lab without a B grade airlock, same grade?
And this question is addressed to who?
I think it's Yuka, is it?
Yuka?
When people go from C grade to B, then there is a airlock where they change clothes. I think that it from this it showed quite quickly, but there is a separate airlock there.
Okay, so there was an airlock there.
UK, if I understand you right, so there is a grade B airlock.
Yeah.
After the grade B gowning room. Is that right?
Yeah.
Okay. I don't know whether, Antonio, that answers your question.
Okay, no.
Okay, no, that's grand. Okay.
Okay.
So it wasn't on a layout. Okay.
Okay. Any more questions? Okay. Connor, I think we can wrap up then. I have just a few things to go through here.
Okay, well, maybe Leanie, if you'd like to say a few words as we bring this to a close, and we say our thank yous to the organisers and all the speakers and the attendees for their participation.
Yes, I agree. Thank you for participating and looking at what the topics of interest and how we can share our knowledge together. So thank you very much.
Okay. And from an Irish Cleanroom Society point of view, I'd like to obviously thank, first of all, Claire Spear, Peter Marin and Colin Buckley
No problem.
for their input, great presentations. Likewise with Ecolab, Mike Wood, John Jones and Barry Fitzgerald. I'd like to thank you guys, great insight as well. Obviously, Lenny, thank you very much. And Yuka, thank you very much. I'd also like to thank our Irish Cleanroom Society, our admin, Flo. Obviously, thank Connor for his input into all this. And Nasida, special thank you to you. You're on the other end of the line anytime we look for anything. So I'd just like to thank you. And the work you do is great. So with that, guys, we'll sign off. And again, don't forget the ISCC 50 years old this year. Symposium is in Antalya. So go have a look at our website. Very great event. From my past experience at these events, they're very knowledgeable, and I think anybody that can go should try to attend. And if you can't go, there are some presentations, hybrid presentations. So again, if you look at the website or your local Cleanroom Society website, you get information. So thanks, guys, again.
So, Chris, just to note on the chat line, there was questions asked, would the recording or presentations be available? I've asked her to confirm that. My understanding is the reason we are recording it is so they will become available on the ISCC’22 platform, and I believe the presentations in PDF will also be available. I presume, UK, you've no objections to sharing your slides?
No, it's okay.
No, and I'm sure Peter and Colin and Barry and Mike would be the same.
No, that's absolutely fine, Connor.
Lovely, thank you very much. So, on behalf of the ISCC, on behalf of the Turkish Cleanroom Society, we're hosting the symposium in Antalya. This is the third webinar. There's a fourth webinar which you'll see. It's in September. I can't see the date just yet because I'm on screen at the moment. But if I look at the agenda, it gives a date when the next one is. And let me just see what that is. What the fourth one is. The fourth one is. Probably need my glasses. Okay, I need to get back to the agenda on this. Okay, forgive me, it's not showing on my agenda. I know there is one on the. There's a fourth. Yeah, sorry, the fourth one is on the 4th of September. Let's see the details on it. Okay, it's not published yet what the details are, but it will be. Keep an eye on the website. You will get a notification from the ISCC organisers of the fourth webinar, but it's on the 4th of September, and I believe it's showing at Now it's showing 7 a.m. on my screen, but I'm in Copenhagen at the moment, so it doesn't show GMT. But look, keep an eye on it there. Thank you very much again for all your attendance, to all the speakers, and Chris and Lini and Yuka, Peter, Colin, Barry and Mike. And on that note, we close it.
Thank you all.
Look forward to seeing you next time. Thank you very much.
Thanks all. Take care. Bye-bye.
Yeah, thank you.
And thanks to Nursida and your team.
Thank you very much, guys. Thanks.
Okay.
See you soon.
Cheers. Bye.